In this video we're going to have a look at factorising difference of perfect squares. So difference of perfect squares, let's call it DOPS for short, okay, difference of perfect squares. We've got a formula, okay, basically it tells us that if we have the square of a number subtracting the square of another number, we get a plus b, a minus b. Okay, so essentially it can be factorised. So we've got a squared minus b squared, a plus b, a minus b. Alright, so that's it's quite a useful formula when we're talking about difference of perfect squares. So applying this formula, basically, if we've got x squared takes 16, for example. Alright, x squared takes 16. 16 can be written as a square. Okay, 4 squared. 4 times 4 gives us 16. Alright, so essentially what I've got is x squared minus 4 squared. Now because I've got something squared minus something else squared, I can apply this formula. Alright, a plus b, a minus b. In this case, I've got my a term as the x and the b term as the 4. So instead of a plus b, what I'm going to have is x plus 4. And instead of a minus b, it's going to be x minus 4. Alright, so it's a really quick way of being able to factorise the difference of perfect squares. I'll just do another example. Let's say we've got 9a squared minus 4b squared. Alright, so 9 can be written as 3 squared, and then we've got an a squared, and then 4 can be written as 2 squared, and we've got b squared. Now using some index laws, if I've got something squared times something squared, I can say let's put them both together, 3 and a, and square them both at the same time. Alright, so this is using one of our index laws, and same thing for the 2 squared b squared. I can say 2b, and we're going to square both of them. Now, instead of just one letter or number, okay, x squared or 4 squared, now I've got 3a squared and 2b squared. So to use my formula, basically what I'm saying is a is going to be 3a and b is going to be 2b. So technically speaking, I've got a squared minus b squared. So when I go to factorise, when I'm talking about a minus b, instead of a, I've got 3a. So I've got 3a minus b, which is 2b. And then 3a plus 2b. Alright, so that's factorising by breaking it up into smaller parts. Okay, difference of perfect squares. Let's say I've got 12y squared, take 1200. Okay, so some of these questions, they're not quite easy to work out straight away. What I need to say first is there's a factor between these two numbers. The number is 12, because 12 times y squared gives me 12y squared, and 12 times 100 gives me 1200. Okay, now the reason I do that is because I've got a 12, I've got a y squared, and instead of 100 I can write as 10 squared. Now, referring back to our difference of perfect squares, I've got an a squared term, which is y squared, and a b squared term, which is 10 squared. So just on the side, I'm just going to write a is going to be equal to y, and b is going to be equal to 10. Because when I use the formula, I'm going to say 12, it's going to be y minus 10, y plus 10. Okay, and then that's factorised. Final question is x plus 3 squared minus 4. So similar to all the other ones, I've got an a squared term. It's not really easy to see, but it's basically x plus 3 being squared. So a is going to be what's inside the brackets, x plus 3. And then my b squared term, 4, well, 4 can be written as 2 squared. So I'll just write that as 2 squared, essentially. 2 squared. So b is going to be 2. Right, because if b squared is 2 squared, then b must be 2. Now, all I need to do is put my brackets. I've got x plus 3 for my a term, minus my b term, which was 2. And then x plus 3, then add my b term, which is 2. And finally, I've got x plus 3 take 2. 3 minus 2 gives me positive 1. 3 and 2 over here gives me plus 5. So factorised becomes x plus 1, x plus 5. So that's factorising using our difference of perfect squares. Alright, so I'll just put a box around this. Okay, so that's the formula that we're going to be using if you're looking at perfect squares.